Today we would like to show the integration of the EtherCAT I/O link master from Siga into a TwinCAT 3 PLC environment. First of all, the device description file needs to be saved in the TwinCAT folder under Config, I/O, EtherCAT. If TwinCAT is already running, it needs to be restarted now. First of all, the PLC needs to be set to config mode. Only if the system is in config mode, it is possible to scan the hardware. Please select here your network access and scan all connected Ethernet slaves and activate free run. The I/O link master shall now appear in the tree structure. The first step is setting the EOE feature. Select the I/O link master in the EtherCAT tab, Advanced Settings, Mailbox, EOE. As default, EOE is activated. If you do not want to use the EOE feature, the checkbox shall be deactivated. If you want to use the feature, a valid IP address needs to be set. In this example, 192.168.10.50. For configuration of the I/O link master ports, the tab Slots needs to be open. In this tab, it is possible to configure each I/O link channel. In this example, an I/O link device with a process data length of 2 bytes is connected to channel 1. All other channels, even if these are not used, need to be defined as well. Select a standard input module if no I/O link sensor is used. Additional slots can be defined here as well. In this example, this is not needed. The next step is to combine the process data of the hardware configuration with a variable in the PLC program. For this purpose, the PLC program is selected, opened, and a variable is set that is linked later on. Only variables with an AT declaration can be linked with available hardware. The length of the variable needs to be the same as the process data length of the connected sensor, in this case 2 byte. In order to finalize it, the project needs to be compiled by clicking on Build IOLM. Now the hardware, Module 1, is opened and both process data bytes are selected. By right-clicking and select Change Multilink, a variable can be assigned to the 2 selected bytes. This is the just set variable, and we link the 2 bytes with this array. Afterwards, the configuration is activated by clicking TwinCAT Activate Configuration. Then the TwinCAT runtime is started and the connection status of the I/O link master can be displayed and checked. Select the I/O link master and the Online tab. The I/O link master must be in operation status, OP. If this is not the case, the error list will show an error or a warning. For visualization of the connected sensor's process data, click in the hardware tree on the specific port. The current value of the sensor is directly visualized. The next step is to set the startup parameters of the I/O link master. These parameters are an option and not compulsory. Switch to I/O link master and select the Startup tab. All variables that are displayed in this list will be implemented during startup of the I/O link master. In this position, the index 2002 subindex 2 is displayed, which is the validation type of port 1. By double-clicking the variable, a second window opens which allows to enter a value. In this example, the port is set in a way that it can only communicate with one specific I/O link sensor. This value is taken from the manual. Validation type 1 is required, which implies that the master checks during startup whether the sensor has the correct vendor as well as device ID. Now we switch to index 8000 subindex 4 and set the device ID of the connected sensor. The device ID is taken from the IODD file. The vendor as well as the device ID can be found in the beginning of the IODD file. Open the index by double-clicking and click on Edit Entry and enter the device ID from the IODD file. Close the dialog by clicking on OK. The vendor ID needs to be changed as well. Double-click the entry and click on Edit in order to insert the vendor ID taken from the IODD file. Each change in the hardware configuration needs to be transferred to the PLC. This is done by clicking on the TwinCAT tab, Activate Configuration. In order to check the just set startup sequence, select the IO-Link master and open the tree, select the folder IO-Link state inputs and select port 1 and switch to the online view. Here we can check whether the sensor is in communication mode. Value 3 shows that the sensor is currently in communication mode. If no sensor is connected, the displayed value changes to 160, which is in hexadecimal A0. If a wrong sensor is connected, the value 48 is displayed, which is 30 in hexadecimal and is defined as an invalid device ID. Not only the process data, but also the service data can be displayed in the hardware configuration. For this purpose, change to the IO-Link master and select the COE Online tab. This view shows all available COE objects. The COE objects are described in the manual. For requesting service data on port 1, the COE channel 4000 is selected. In this example, the vendor ID shall be read. Click on Index and type in 16, which is the vendor ID. For reading the value, the subindex 1 needs to be set to 3. The status shows 2, which is done. The length parameter shows how many data bytes have been read. The subindex 6, data, shows the read data. By double-clicking on the value, this data can be evaluated. Click on the hex editor and the ASCII code is shown. In this example, the read out vendor ID is SIG-AG. This procedure can also be done with the COE function blocks during the PLC runtime. Open the Internet Explorer and type in the IP address of the master that has been used in the EOE feature. Click on the Diagnostic Process tab. A process data change looks like this. The status of pin 2 is represented. Next, click on Device Properties. To get service data from a certain port, this port needs to be selected. To get the vendor ID, index 16 with subindex 0 is requested. The displayed hex stream shows SIG-AG. The following screen shows the status of the IO-Link master. For more information, contact us on sig.com.